session. Our old topic was ECG for the beginner, part 9, basics and principle of the ECG. In today's lecture, we are going to discuss about the vector. What is the vector? What is the vector? Vector is defined as a quantity which has both magnitude and direction. Vector is defined as a vector is describing as a quantity which has two things. One is magnitude, another is direction. Later on I will give detailed information about the magnitude and direction, but right now we should know about the definition of the vector. After the definition of the vector or a simple definition is also present for the vector. A direct segment line. A direct segment line is also called vector. In the ECG, vector is represented by an arrow. Vector is used in ECG, in cardiac, and in mathematics, and in physics. We use the vector in different fields, but today in our minutes here is physics. Every force is presented by a vector. The vector is made from two main parts. One, the length of the vector, another is the height of the vector. Parts of the vector. Vector is made from two parts. One is length of the vector and another is height of the vector. Length of the vector represents the amount of the electrical force. Length of the vector represents the amount of electrical force or amount of electrical potential. And height of the vector represents direction of the electrical force. Length of the vector. If we have got longer vector, it means we have got more electrical force. So that the amount of the force which is objected by something, it is quite related to the length of the vector. So longer vector, more electrical force, small vector produce small electrical force. The amount of the force is directly or proportionate to the amount of the electrical force which is produced by an object. The length of the vector is directly proportionate to the amount of the electrical force which is produced by an object. For example, SNO is a small tissue. They produce small wave or a small electrical potential. This is so small it does not detect by the electrode because we have no any vector from the SNO over the ECG paper. Length of the vector is represented amount of the electrical force. Height of the vector represents direction of the electrical force. This two things is very important in the ECG. In addition of these two things, vector also provide information about the conduction of the electrical force and also speed of the electrical force. So vector represent or provide information about the amount of the electrical force, longer length vector, large amount of electrical force, small vector produce a small amount of the electrical force. So in final, vector provide information about four main things. First, amount of the electrical force. The second, direction of the electrical force. The third, conduction of the electrical force. And finally, speed of the electrical force. We practically see these four things in the ECG. Right now we will be discussing about the practical role of vector in the ECG. First, we come to the SA node. SA node is a small node which is made from small cells. This is a tiny tissue. For depolarization of the SA node, we need calcium. So this is small tissue. I mean SA node, does not produce enough electrical voltage or electrical impulse which is detected by the electrode. So and therefore we don't have any wave or diffraction from the SA node over the ECG paper. But directly we know from the stimulation of the SA node. This is the SA node will stimulate the atrium. A well-defined P wave representation of the activation of the SA node. So we don't have any wave or deflection from the SA node because of the two or three reasons. One, it is a small tissue. The second, it is made from less cell. The amount of the calcium which is required for depolarization of the SA node, this is also less, and the conduction system of the SA node is also slow. That is why we don't have any wave or deflection from the SA node over the ECG paper directly. But indirectly we know that the SA nodes is
Yeah,
because if you have got a well-defined P wave over the ECG paper, it means this atrium is stimulated by SN node. And this was about the SN node. And SN node does not produce any wave reflection over the ECG paper because of this reason. After the SN node, we come to the atrium. Atrium is larger than the SN node, but smaller than the ventricle. The SN node first produce the electrical first group of the cell, second group of the cell, third group of the cell. Finally, the atrium is stimulated by the SN node, especially right atrium is stimulated by the SN node. And also left atrium is also stimulated through the Bachmann pathways. But we don't have two atrium over the ECG paper. So right atrium is also produce a vector and left atrium is also produce a vector, but they are small vector. But over the ECG paper we have got just one wave, which is called P wave, because the right atrium and left atrium are electrically connected to each other and they produce a single wave over the ECG paper, which is called P wave. Did you catch this one?
Yes. Because of dual chamber concept.
Yes, that is good. After we come to the AV node. AV node is a small tissue, tiny tissue, but the electrical conduction in the AV node very slow. This is why we don't have any wave or deflection over the ECG paper. But during this period, we just have a straight line. After the AV node, we come to the ventricle. The ventricle first electrical potential goes through the left bundle branch, and this left bundle branch stimulate the septum, and the electrical force go from left to the right, and septum also has a small tissue and tiny tissue. But we have got a small wave over the ECG paper. In the standard limb lead, this septum is represented by Q wave. But in the precordial lead, it is represented by septal or septum. So septum is also a small tissue or a tiny tissue, but it is less from the atrial tissue, and that is why we don't have any wave from the SN node, but we have got wave from the septum. This was septum produced in the standard lead Q wave, and in the precordial lead they produce R wave. Right now we come to the ventricle. First the electrical impulse leads to depolarization of the right ventricle, and then the electrical force goes to the left ventricle. Both ventricles are electrically activated together because of the electrical connection or gap junction. So these two ventricles, both of them are activated at the same time, and they produce a large wave, which is called R wave. This Q in the standard representation of septal. This is septal. This is ventricle. And this is also sometimes in this basal part. And the second is to represent basal part depolarization. So in the standard lead, this negative Q wave which comes here for the R wave represent the septal. This R wave represent the major part of the ventricular depolarization, and this is RSR, and this is also represent basal depolarization, like this. This is the basal ventricular depolarization. So what else? What is the vector? Vector is defined as a quantity which has both magnetic and directions. This is about the definition of the vector. Part of vector is represented by an arrow. Arrow have got two main parts. One of them is the head, another is the length part. Longer object or big object produce more amount of the electrical force, so the vector represent the length of the longer vector. Small object produces small electrical force, so it produces a small wave or deflection over the ECG paper. Direction of the electrical force. For example, electrical force produced here. This electrical force goes to B point. So the direction of the electrical force may be from A to be. For example, when the electrical potential is produced from the S anode, and this S anode first leads to depolarization of the right atrium. Right atrium goes downward and leftward, and the left atrium produces electrical depolarized by the S anode, and they come downward to leftward. So both vectors are connected to each other and produce a single wave over the ECG paper, which is produced T wave. This one. The second length of the vector represent amount of the electrical force. Height of the vector represent direction of the electrical force. In addition of that, this vector provide information about the conduction or path, and then the second speed. For example, arterial tissue is supplied by moderate conduction system. So this electrical force moves with moderate conduction or speed. Yes. The second conduction. The conduction system of the arterial is intra-arterial conduction system. Superior intra-arterial, middle intra-arterial, and posterior intra-arterial. So this was the conduction system. They provide electrical force. In addition of the electrical force, length of the vector represents amount of the electrical force, direction of the electrical force, speed of the electrical force, and finally, conduction of the electrical force. Vector have provide for us three more important things. Number one, amount of the electrical force, direction of the electrical force, speed of the electrical force, and through a path or a conduction system. This is very necessary for the definition of the vector. The second, why S anode does not produce any wave or deflection over the ECG? This is the one reason. Another, calcium channel, calcium depends to the S anode depolarization depends to the calcium. Calcium compared to the S anode, this is also have got a slow conduction. So therefore, we don't have any wave or deflection from the S anode over the ECG paper. Right now, we will come to the atrium. Do you have any wave from the right atrium over the ECG paper? From the right atrium?
No.
What is the reason?
Simultaneously, they can try to.
Because the right atrium and left atrium are electrically connected to each other. So over the ECG paper, we have got just one wave, which is called P wave. What about the AV node? Do we have any wave or deflection from the AV node? No. What is the reason? It have got three reasons. One, this is also small tissue, tiny tissue, made from small cell, need less calcium. In addition, the conduction system of the AV node is slow. This is the reason that electrode does not detect any electrical impulse from S node and AV node over the ECG paper. So, and therefore, we don't have any deflection or vector over the ECG paper. The second, do you see any vector or deflection from the right atrium over the ECG paper? Do you see any wave or deflection over the left ventricle, over the ECG paper from left ventricle? We don't have, because the right ventricle and left ventricle have both of them produce a vector. But the left ventricle thicker than the right ventricle, so they produce a single vector. A single vector moves toward the positive electrode. The deflection in the needle of the ECG machine would be positive. Arterial tissue is also moved toward the ECG, toward the positive electrode. The deflection in the needle of the ECG machine would be positive, which is called P wave. Septum. Septum is also small tissue, tiny tissue, but we have got any wave or deflection from the septum. Do you see any wave or deflection over the ECG paper from the septum? Yes. In the standard lead, Q wave, and in the precordial lead, septal. And finally, do you have any deflection from the right ventricle and left ventricle? We don't have, because electrically connected to each other through the gap junction. And finally, ventricle depolarization needs three stages. First, the electrical impulse leads to depolarization of the septum. After the septum, the right ventricle. After the right ventricle, left ventricle. Totally, both of them together contracted, and they produce over the Q or S complex. What is we say the vector? For example, this is P the vector. After the P, there is a straight line. Then there is a Q line. This is another vector. And this QRS complex. This is another vector. And this is another vector. And finally, this is another vector. This is, all of them are vector. But in the ECG, they write just like this. What is the role of vector in the ECG? Yeah. When we are talking about the vector, we should think about the electrical force. When we talking about the wave, we should think about the electrical force. When we have got downward or upward deflection, we should about the direction of the electrical force. When the electrical force in the left ventricle produce large wave, large deflection, but rapidly and fastly with the fast speed. Because the ventricle system is supplied by Purkinje fiber. Purkinje fiber rapidly and fastly transmit the electrical force to the myocyte and produce the ventricular deflection. Now, do you want to tell me something about the vector?